Hello everyone and welcome on today's video. My name is Wouter Peer and I'm the founder and main developer of GG2 Cloud. And today we will be continuing our discussion about the imbalance, but from a different perspective. Namely, today we will be covering how to avoid imbalance. Now let's recap once again what is the imbalance. Now the imbalance is the yearly heating up or cooling down of your ground, of your borefield. And it's mainly determined by your building load. So again, this figure, if you have more extraction, so your building has a higher heating demand, you extract more heat from the ground than you're injecting back into it. And this difference between the extraction and the injection is called the imbalance. And it can be either positive or negative, depending on whether your injection or your extraction is higher or lower. Now, in this case, the extraction is higher than our injection, meaning that year after year, our temperature of our bore field will go down. And this imbalance is a problem when it comes down to geothermal design, because if you want your field to be sustainable over the long term, you have to take this imbalance into account for your design. So the more imbalance, the bigger your bore field should be in order to be able to withhold too low temperatures over the long term. So that's why we care about imbalance. Now, there are two ways to look at this problem. I've said that the imbalance is a given for a certain building, and that's true. But of course, the building itself is not a given. And there are architectural choices to be made, there are quite a lot of HVAC choices. But once all these choices are made, we end up with a certain imbalance that can be given to a design software like GG2 in order to design your bore field with it. And that last part was exactly what we discussed about last time. When we have a certain imbalance, which is given, how can we design our bore fields in such a way, or which design choices can we make in order to come up with a sustainable, affordable bore field? Now today we will be taking a step back and thinking about the problem, okay, how can we avoid the imbalance? Because if we don't have an imbalance, we don't have to solve it when we're at the geothermal design stage. And there are two different approaches to, let's say. We can look at this problem from an architectural point of view, and then we're trying to influence the building load itself. Or we can look at it from a system approach, and then we're influencing the geothermal load. And we will cover both in the next minutes. Now, let's start with the architectural approach. We said that the imbalance is a direct consequence of the building demand, which is true, but of course this building demand depends on architectural choices. And one which is typically debated is the one of sunscreens. So in summer, when you have quite a lot of sun coming into your building, risk is that your building starts overheating, that it's too hot and that's not comfortable. So that's why more people are installing blinds, solar shades, in order to try to keep out the sun as much as possible in summer to keep the building nice and cool. But of course, if you have less sun penetrating in your building, there is less cooling demand, and hence there is also less heat that's being re-injected into the ground. So if you have a building that has already a problem with extraction, that extracts more heat into the ground than it injects, placing solar screens will only make this worse, because the solar screens will take away part of your cooling needs. And if you take away part of your cooling need, you're injecting less into the ground. So your imbalance can become bigger. And this is only one of the many architectural design choices that influences our behavior, our demand profile. And typical questions are the window size and orientation, where bigger windows will lead to more solar gains in the summer, so a higher cooling demand, and hence more injection into the ground. But of course in winter, having a bigger window will lead to more heat transfer losses, increasing the demand for heating and hence the energy extracted from the ground. And what is also important in this window debate is where the windows are placed. Because if you, for example, place a big window on the north side of your building, you know that there will be almost no solar gains because there is no direct irradiation on the north facade of a building. So this window will most probably only attribute to more heating losses and increasing your extraction from heat from your bore field. Whereas on the other side, if you place your windows on the south side, there is quite a lot of sun entering in summer, increasing the cooling demand and leading to more cooling demand and hence also heat injection. What is also important as an architect is to think about the U value, not only of windows but of the whole building as general. How well is the building insulated? This has an effect on your heating and cooling demand. The G value of your windows determines how much sunlight penetrates, also attributing to both heating and cooling demand. But also things like trees or self-shading, where parts of the building shades different parts. This also influences the heating and cooling demand. And then you have things like ventilation systems, CRD, with heat recuperation on the air handling unit. Quite a lot of architectural choices that finally influence our heating and cooling demand and hence also our imbalance. And one of the most common design choices, I should say, is related to the floor, because it's an aesthetic choice. And I've put here two floor heating systems, one with ceramic tiles on the right, on the left better, and on the right we have a hardwood floor. Now there are aesthetic reasons to opt for one of the other, but what is important is that there is a 50% difference in emission capacity between ceramic tiles, which conduct heat very well and is good for floor heating and floor cooling, whereas our wood floor is not very good at it, because wood is kind of an insulator, and the harder your floor, the harder or the thicker your wood layer, the worse thermal behavior. So when you have a high imbalance in extraction, you're extracting more heat than injecting, and you rely on passive cooling with your floor to regenerate, to put heat back into the ground, having a hard wooden floor will actually prevent that, because there is quite a lot of resistance from the heat to travel from the air to the floor cooling system. So this is an architectural approach or an architectural choice that has quite a lot of influence in not only your comfort, your aesthetics, but also the imbalance of your system. Now that was everything I wanted to say about the architectural approach or choices. The other category is everything related to the system, the HVAC system as a whole. And if you think about this range of solutions, we have two groups, the hybridization and the regeneration. Now, related to hybrid systems, we already spent quite a lot of time talking about this on this channel, because it's one of the big powers, one of the big advantages of GeoTool is that you can actually simulate this. And before we start diving a little bit into this, I want to mention that what we said about the imbalance, that's a direct consequence of the building, that's true, but it's more specifically the part of the building demand that's actually fulfilled by the borefield. So I have here a same figure as before, with the extraction load bigger than the injection, so if an imbalance, ground cools down year after year. And what we can do is we can say, well, let's take parts of this extraction load from the borefield and place it onto air to water heat pump, for example. Now, our building demand has not changed, that was determined by architectural choices, but due to our system design, we're taking parts of our heating demand away from the borefield, whereby we lower the extraction from it and we remove the imbalance completely. So by placing another technology and making our system hybrid, we can balance or take away the imbalance completely. Now, these hybrid systems, as we discussed, they occur for more bigger building, commercial building, multi-utility buildings, but also in residential sectors you can have them. And one of the typical hybrid systems in residential houses occur when it's a new built house, we have floor cooling and heating, but in this case floor cooling is important. But the summer comfort is not met. It's too hot in summer, so our client installs a split unit, a traditional air conditioning unit, to really boost cooling in summer. So we now have a hybrid system, part of it with the floor cooling, part of it with the split unit, part of it is geothermal, and another technology is air-based. Now, you can think, oh, hybrid system, nice, we can solve quite a lot of problems with this. But the problem is that this split unit, it will cool down the air in the room to easy 21 degrees. Nice summer comfort. But the problem is that at these temperatures, there is no more passive cooling. There is no more free cooling because the air in the room is already too cold to be able to transfer heat to the floor and to the geothermal system. So the problem is that in this case, when we use our split unit for peak cooling, there is an increased demand in imbalance. So what we do is we decrease the amount of injection because part of it is taken away with our split unit, and our imbalance will grow, and hence will be the consequences for our geothermal design. Now, one nuance I want to make here, if you install the split unit and you use it also for heating, that's actually the good thing to do, because then we will take away part of the heating demand, we will decrease the extraction from the ground, and our imbalance will be lower. But typically, I see this in projects almost everywhere. People install split units, and then there is less regeneration with the ground. The passive cooling will be less, and hence the imbalance will be bigger. So that's really something to pay attention to when your client demands for that. Now, next to hybridization, there is another set of solutions which is called regeneration. So instead of stating, okay, we're going to install another technology that can take part of the building load from the borefield, we can say, okay, we have this imbalance, we have the same imbalance as before, but now we're going to install a dry cooler, solar absorbers, PVT or hybrid solar panels to actively compensate for this imbalance. So in this case, we have more extraction than injection. So what we can do is we can actually say, let's increase the amount of heat we inject into the ground by, for example, using a dry cooler in mid-season or in summer. It captates the heat from the surrounding air and it puts it back into the ground. So by actively injecting more heat into it, we can avoid the imbalance, we can take away the imbalance, but in a different way than with hybridization. And you can do the same if you, for example, have more injection and extraction, then you just have to make sure that you extract more heat with another technology to balance your borefield. So this is what I wanted to talk to you about today. So let's summarize. How can we avoid the imbalance? Now, the imbalance is something which gets created during the building's design stage. And it's better to think about your geothermal balance during the design of your building, both architectural, but also from a system point of view, and not afterwards. Because then you have to cope with the imbalance and you have to change quite a lot about your geothermal design in order to cope with the imbalance. And that we discussed last time. So when it comes down to architectural choices, there are quite a lot of decisions, mostly related to window and the location and its sizes, the screens, but also the type of floor you use has an impact on the imbalance eventually. When it comes down to the system, we have both hybridization and regeneration options, where with hybrid system, we're taking away part of the building load from a borefield, whereby it's balanced. And with regeneration, we're going to put some extra load onto the borefield in order to actively compensate for the imbalance and to balance it in the end. So I hope you found this video interesting, and perhaps it's something to share with your friends in architecture or installers or in the broader geothermal domain, Because in the end, as a geothermal designer, you have to design your bore fields in such a way that you can cope with the imbalance. But if you can avoid the imbalance, or someone else can avoid the imbalance, it's easier to do your job right and to make, in the end, a better HVAC system and a more affordable HVAC system. So consider subscribing, sharing this with friends, family, colleagues, and I'm looking forward to seeing you in our next video. Take care. Bye.